2, adding and subtracting. Now, how do you do adding and subtracting? I told you there's no, let me skip the first one because you can always get that one right. Let's do this one here. There's no real addition and subtraction rule, not like multiplication and division, okay? Where you could rip up square roots into 2 parts horizontally and vertically. You can't, there's not much with addition. Here's your adding things. So let me clear this out. Don't save it. Show you that it's not that bad at all. So new, okay. Let's move this over here, move this over here. Okay. 3 square root of 6 is added to 6 square root of 6. The way you do this is the same way you would do this problem. Forget the square root of 6. Make it a variable x. If I gave you 3x plus 6x, what would you do? How do you add 3x plus 6x? What's the answer to that?
9x.
9x. That 9x. Like terms, right? 3x's plus 6x's are 9x's. These are like terms. Square root of 6 are like terms. So that means this and this are like terms. They match in the square root of 6. So you got 3 of them plus 6 of them. That's how you do these problems here. There's, no, that's not right. 3 plus 6 is 9 square root of 6. That's the answer to that problem. That's the key to doing adding and subtracting of expressions. Like terms. All right, like terms. That's the answer. I'm not going to waste time doing that one. Let's do another one. So what do you think this answer is? Let's see if we can do it without using any. Geez, let's make it bigger. Okay, what do you think that answer is?
10 square root.
10.
16.
No.
Oh, minus 6.
Minus. You got, these are your like terms. You start off with 8 of them, minus 2 of them. You got to have 6 of them left.
Oh, 6. Oh, okay.
Okay, just ask yourself, what would you do if this was 8x minus 2x? I got to believe you'll tell me 6x. If you wouldn't tell me 6x, I'd cry. This would be, but these are not x's. These are square roots of 5s, but they're like. This term and this term are like. If this was like the square root of 7, pretend 2 square root of 7, they're not likeness. There's no likeness there. And if there's no likeness, you can't simplify them. They're going to give you likeness in the first few problems. So check your answer there. There's your answer. What do you think?
I love it.
Not bad.
Far? You think there might be more to this than it is. There really isn't.
That's
There
true.
really isn't. What do you think this answer is? Looks complicated, right? Got 3 terms.
20 square root of 6.
Yeah, that's right.
Yeah.
You got, they're all likeness. You got 8 of them plus 5 of them is 13 of them. 13 of those square roots of 6s plus another 7 of them are 20. Yeah, there you go. 20 square root of 6.
But I have a question.
Yes.
It looks easy because all the square roots are 6. But
Yes.
imagine that we have different, square roots.
Very good. Very good. Very soon we're going to see that problem. We're going to see that problem. Another couple. Okay. Not all these problems can be done. Not all. I mean, in reality, if this was like the square root of 7, then that square root of 7 cannot be combined with the square root of 6. You can't do it. You just got to leave it alone. Okay. You just got to leave it alone. But right now, they're starting you off with all like terms and great. Just combine the whole number parts. Now, this guy here looks a little, that's something that needs to be written out here, I guess. This has got the variable in front. That's a t. Square root of 3 plus 4 t square root of 3. I'm happy. These are like terms. You've got two square roots that look exactly the same. So what you're going to do is you're going to take this 5t, add that to another 4t. So what happens when you got 5t plus 4t? What do you get?
90.
9t. See, whether you have a variable there or not, you still add the coefficients. Square root of 3. Another way to do this, another way to say this is factor out the square root of 3. If it's like terms, I should be able to factor it out. Leaves you with 5t plus 4t in the bracket, in the bundle, and you can combine that to be 9t that you put in front. 9t, square root of 3, square root of 3. Check your answer. Nice work. All right, what do we got next? This is, you can do that one. That's the. And actually, you can do this one too. I mean, the square roots are exactly the same. What's underneath the square root is a bundle, y minus 2, y minus 2. You start off with 3 of those weird expressions, square root of y minus 2, minus 1 of that same expression. Got to be 2. What you're left with is 2 of that expression, y minus 2. Now, Franz is chomping on the bits. He wants to know, what do you do if they're not the same square root?
Yes.
I think the next one is what you do. There you go. There you go. Let's see. Right now, these two things are not like terms. So right now, you can't touch them. Can't touch them. Don't save. Don't save. File, new. Okay, start fresh. Yeah, we can write it down on our paper. 775 minus square root of 48. Now, they're not going to give you a problem you can't simplify. I'll tell you that. There's probably something you can do to make it work. What you're going to need to do is look at these numbers, 75 and 48. Can you break those down with perfect squares? All right, can you break those down with perfect squares? So just take a look at the square root of 75.
Something happened to the screen.
Huh?
Something happened to the screen.
What happened to the screen?
Your WordPad thing went away on mine.
No, it works for me.
Oh, it's telling me my session ended. Never mind. Go ahead.
Oh, okay. Yeah, move the mouse around. Move the mouse around. Okay, so square root of 75. What's a perfect square that goes into 75? 25 is a perfect square times 3. All right, so square root of 25, I can rip this up into 2 parts. Square root of 25, square root of 3. That's what that first one is. Okay, that column. Square root of 75 is equal to square root of 25 times 3. Square root of 25 is 5. Square root of 3 is 3. Square root of 3, can't do much with that. Bring down the minus. 48. What's the biggest perfect square? Looks like 16 times 3. Now ripping these apart, square root of 16 is 4. Square root of 3 is square root of 3, and guess what? There you go. See? From something that doesn't look the same to something that looks the same. Square roots of 3. You got 5 of them minus 4 of them. You got 1 of them. Don't write down 1. There's your answer. I could write down 1. Okay, but it looks dumb. I don't want you to look dumb. So that is the answer for that problem right there. What do you think? Does that make you a little bit happier, what you're going to do?
Mm-hmm. Yeah.
Okay, now we'll do a few more of these, of course, here. Let's see what we got next. This is 2 square root of 125. So right off the bat, 2 of them, right? Don't check don't click check answer. You're not going to get it right. because this square root of 125 can be broken down into two parts, into a perfect square. 2, that's the 2 in the front. Square root, what's a perfect square that goes into 125?
My gosh, I'm not awake.
$1.25 is 5 quarters. A
Yeah.
quarter is a perfect square. Square root of 5, right? See, these two guys merge together into 1 square root of 125, so I know that's right. Equals 2 times, I wish there was a times sign there, times square root of 25 is 5. Square root of 5 is what it is, so we'll write that down. And 2 times 5 is equal to 10. There's your answer. What's up? Okay, let's get rid of this. Be careful not to delete it all. Okay, check it. Well done. Well done.
I have a question.
Yes.
If you do the reverse, you know, if you have a problem like 10 square root of 5, can you find in the end square root of 125 plus square root of 125? Can you do the reverse?
I'm saying, say that again, like this problem right here.
Yeah, but the solution is 10 square root of 5.
Yes.
But if you have a problem that is 10 square root of 5, can you find 125 like it is, you know, at the very beginning?
Yeah, because it comes out to 250.
Oh, no, you could, oh, whoa, no, don't do that. The square, you cannot do what you just said. The square, this is not the square root of 250. Okay, this is a bundle and this is a bundle. You can't add what's inside the bundles. Okay, the best you can do is what I just said there. Let's do a similar question. Oh, it's not the similar question, damn it. Let's come over here. 64, this is like what they had before. No, 25. How about this? Square root of 128 plus square root of 128. Think of that square root as a bundle. You cannot go inside the bundle and just add things together. Can't do that. The best you can do is say, well, I got one of these plus another one of those, and that's going to be 2 square root of 128s. That's correct. Okay. Now, just focus your eyes on that. Can we break down to 128? Yeah. Square root of 64, square root of 2. Okay. Square root of 64 is 8. 2 times 8, those are whole numbers I can multiply. 16 square root of 2. That would be the answer to the problem. So please don't go in there and just come up with your own math. They're bundles. You can't go inside the bundles and combine them. Okay?
Yeah.
All right, clear it. File clear, file new. Okay, we'll do that. Close this. Don't save. All right, what's the next one? You know what? I'm going to do this one here. I'm going to do this one. That's a harder one. That's the harder one. If you can do this one, you can do the previous one. So negative 15. The whole idea behind, as soon as you see a plus sign with the expressions that have square roots, you got to find a common like term. That's the only way to do these problems. And not all problems can be done. Okay, not all of them can be done, but they're going to give you problems that you can do. Okay, but in reality, in the world of mathematics, not everything can be done, and they're not going to frustrate you by giving you problems that you can't do, that you can't simplify. So there's what we're starting with. So right now, those square roots don't look the same at all. They don't look the same at all. So what you want to do is just focus on the square root, rip it apart. That's the best we can do, and hope for the best. That negative 15 is what it is. Leave it alone. but I'm going to rip up that square root of 18 from the square root of n. Just copy the rest down, 4. I'm going to rip this apart, square root of 50, square root of n. And I'm sort of happy because I have two square, this one has a square root of n and this one has a square root of n, so they must, there's likeness there. So, but let's not be too happy right now. Let's take the square root of 18. What can we do with square root of 18? Is there a perfect square? Yep, there's a perfect square. Square root of 9, square root of 2. Okay, square root of 18 is the product of two square roots. Don't leave one of them out. Square root of 9, square root of 2 is square root of 18. Let's copy the rest down. Plus 4, 50. I can, there's a perfect square there, 25. And this is the square root of 2, square root of n. Okay. So what do we got going on here? Let's see. Square root of 9 is 3. This is 3. 3 gets multiplied by negative 15 to be negative 45. Okay, 3 times negative 15 is negative 45. And look at this. These two guys marry together into one big square root. Doesn't look pretty, but that's what we have here. Plus, square root of 25 is 5, times 4 is 20. And these guys marry together in one big square root of 2n. And we still got likeness, bigger likeness. That's good. That's good. Square root of 2n, square root of 2n, great. You start off with negative 45 of them, plus 20 of them. Got to be negative 25 square root of 2n. That should be it. Ask yourself, when you got like terms, if you had negative 45x plus 20x, what would you do? Of course, you'd add the coefficients. Negative 45 plus 20 is negative 20x. Negative 25x, rather. Whether you have x or square roots, as long as the square roots look the same, then you do it the same way. Okay? Just add the coefficients to give you this answer right here. Let's see if that's right. Well done. Well done. I'll let you do that one. I'll do this one. I'll do this one. What's the last one? I'll do that one and the triangle, and that'll be it for today. Let's start off fresh. Don't save. File, new. Okay. 45 minus 2 square root of 5 plus square root of 6. Okay. I don't see any likeness, but maybe something will happen if we have the square root of 5. Maybe we can do something with the 45. What's a perfect square that goes into 45? You got to know your times tables. I can't teach you those. 9 times 5 is 45. 9 is special because that gives me 3. Square root of 5. I didn't touch these. There's not much you can do with this. There's not much you can do with that other than copy them down. Because there's no perfect square that goes into 5. Okay. Well, what do we do here? Well, the only thing that's like terms are these two guys. The square root of 6 is not likeness, so 3 minus 2 is 1. Square root of 5. Just copy the rest down. And that's all you can do. Remember, don't add these things up, make a square root of 11. And These are separate bundles that can't be touched. So that's the answer for that problem right there. Okay. All right. I know you're tired. You had enough math, but there's only one more problem. We're done with this. They like to hit you with these. I would have done this a lot different, but they like to hit you with these Pythagorean Theorem problems. I don't know why, but just accept it. Let's come over here. New. Okay. Okay. For this isosceles triangle, that means two sides are the same length. This side and this side are the same length. Find the lengths of the missing sides. All right, let's make a little picture. Ooh. This is 13. That side is 7, and this side is 7. These are right angles. Right angles. And so we'll call this x, and this is x. That's the hypotenuse. So a squared plus b squared equals a hypotenuse squared. 7 squared plus 13 squared equals x squared. Okay, that's a 13. You only have to do it once. This side and this side are the same thing. So this is 49 plus 13 is 169. And that looks like when I add those two numbers, I get 18. 218? 218? Okay. 49 plus 69. I got 69 plus 218.
218.
Equals x squared. X squared equals 1 to 218. I don't want x squared, I want x. So how do I get x? What's the opposite operation of a square?
Square root.
Square root. Whatever you do on one side, you do on the other. Square root of 218. And is there a perfect? The answer is square root of 218. The one issue I have here is they might not take it if there's a perfect square that goes into 218. So what you're going to need to do is go in that table of square roots of perfect squares and see if you get something that divides into 218. And I don't think there is. I don't think that there is. So I'm going to check my answer. Good. There you go. Okay. They snuck another question in there, huh? The perimeter of the triangle. Well, the perimeter of the triangle means you have to add up all the sides. Okay, 3 sides. What you're going to do is, well, starting from here to here is square root of 218 plus from here to here is the square root of 218 plus, what's the distance from here to here? 7 plus 7 is 14. Add up all the sides. And it looks to me that these guys are like terms. So there's 2 of those big square roots. So what I'm going to put in here is 14 plus 2 of those square roots of 218s. And there's your answer. They want radicals. I'm going to say, okay, there's your radicals. And that's it. That's it. No more math today. You're going to do section 8.1. You're going to do section 8.2. And you're going to do quiz 8A. That's what you're going to do. All right?
Okay.
All right. Next Tuesday, we'll see you then.
Okay.
All right, guys.
Thank you very much.
All right.
Thank you.
Have a good weekend.
You too have a great weekend.